Right, now we look at modifying YP. A solution YP of a differential equation that contains no arbitrary constant is called a particular solution to the equation. If any term in the guess for YP is a solution to the complementary equation, we need to modify YP by multiplying the YP by X. Then, repeat this step until there are no terms in YP that solve the complementary equation. Alright, how to guess for YP? We look at this table. Okay, we have the first column, function for Rx. Okay, remember Rx means the function on the right hand side for second order non-homogeneous equation. Okay, and second column is example for Rx, and the last column is the trial solution YP. Okay, let's say if Rx is given in constant. Okay, constant here means, let's say we have constant 2 or maybe constant -1. Okay, so we can write trial solution YP equals to constant A. Alright. If we have Rx in linear function, for example, let's say Rx equals to X, okay, X only means linear function. And maybe linear function 2x plus 1, or maybe linear function 1 minus 3x. So, our trial solution YP equals to AX plus B, right? Let's say if Rx is quadratic function. Okay, for example, x squared only. Okay, x squared only means quadratic function. And maybe quadratic function 2x squared plus 1, or maybe quadratic function 2x squared plus x minus 3. Okay, so our trial solution YP should be ax squared plus bx plus c, right? Alright, let's say if we have Rx equals to exponential function. Okay, for example, let's say Rx equals to 2e to the power of 2x, or maybe e to the power of negative x, or maybe negative e to the power of 3x. Okay, so our YP equals to, for constant in front here, 2, 1, -1 here, we write constant A, and then we just follow the given exponential function. Okay, for example, if we have 2e to the power of 2x, so our YP equals to constant A e to the power of 2x. We use the same exponential function. Okay, but we put constant A in front here. Okay, since 2 here means constant, right? And then if we have e to the power of negative x, we still follow e to the power of negative x, but we must put constant A in front. Okay, because in front here we have constant 1, right? And then if we have Rx equals to negative e to the power of 3x, so we must write YP equals to constant A, okay? And then we follow e to the power of 3x, right? How about trigonometric function? Okay, if Rx equals to trigonometric function, let's say we have Rx equals to function cos only, or maybe sine only, or maybe we have both combination between cos and sine. Okay, Alright, if we have cos only, so our YP must combination between cos and sine. Okay, we must follow the given angle. Okay, if we have cos angle 3x, so we must write cos 3x and sine 3x. Okay, in between must plus, in front cos must A, constant A, and in front sine must constant B. If we have 3 sine x, okay, the angle here is single x. So we must put cos x and sine x, okay. In between must plus, in front cos x, we have constant A, and in front sine x, we have constant B, okay. And if we have combination between cos and sine, we also write YP equals to combination of cos and sine. Okay, we follow the given angle here, which is 2x. Okay, in front cos 2x, we must write constant A, and in front sine 2x, we must write constant B. And in between must plus, right? We look at example 1. Solve the second order differential equation y double prime plus 2y single prime minus 3y equals to negative 3e to the power of 3x. Okay, we have second order differential equation, and then right hand side not equals to 0. So means this is non-homogeneous second order ODE. Right? Okay, so first step to solve second order ODE. Okay, find the general solution YP. To find YP means we need to solve homogeneous equation. Okay, I mean homogeneous equation for second order ODE. Okay, how to solve homogeneous equation for second order ODE? Okay, first, we must write y double prime plus 2y single prime minus 3y. We equate right hand side equals to 0. Okay. After that, we need to find characteristic equation. Okay, what is characteristic equation? Okay, characteristic equation means we replace y double prime by m squared. Okay. And then we replace y single prime by m here. Okay, and m here means m to the power of 1. Y double prime means m squared. Y single prime means m to the power of 1. Okay, or m only, right? And then we replace y equals to 1. Okay, 1 here means m to the power of 0. So we replace y equals to m to the power of 0, which is equals to 1. We replace y prime equals to m to the power of 1, which is m only. And we replace y double prime equals to m squared. Okay, so we got this. Okay, we have m squared plus 2m minus 3 equals to 0, right? Right, after that, we need to solve the quadratic equation. So we can factorize this quadratic equation. So we got m minus 1 times m plus 3 equals to 0. Okay. Then we have two values of m. Okay, we write m1 equals to 1 and m2 equals to negative 3. Okay. So now we have m1 not equals to m2. So this is called distinct real roots, right? Okay, after that, we need to write the general solution YG based on the types of root. Okay? Okay, so the general solution YG equals to, okay, from here we have distinct real roots. Okay, so we look at this formula. Okay, for distinct real root, where M1 not equals to M2, we can write the general solution, the general solution y equals to C1e to the power of M1x plus C2e to the power of M2x. So we use this formula, right? Okay, so from here we can write the general solution YG equals to this formula. Okay, we use this formula. Then we can replace M1 equals to 1 and replace M2 equals to -3. Okay, so we got YG equals to C1E x plus C2E -2x. Okay, this is our YG. So up to this point, we done step 1. Okay, find the general solution YG. Right? Next, step 2. Find the trial solution YP. Means we need to solve non-homogeneous equation. Okay. In this step, we need to identify Rx. And in this question, our Rx, which is right-hand side second order ODE, equals to exponential function. Okay. We recall this table. Okay. If we have exponential function, let's say we have 2e to the power of 2x, e to the power of -3x, negative e to the power of 3x, we must write yp equals to constant a, and then we follow the given exponential function. Right, now we have right hand side equals to -3e to the power of -3x. Refer from this table, so we can write the trial solution yp equals to a e to the power of -3x. Okay, we follow this table, right? Okay, this is our trial solution yp. Okay, let's say we use this yp, which is a e to the power of -3x. Okay, after we find yp, okay, now our yp equals to a e to the power of -3x. After that, we need to find yp prime. Okay, so we differentiate this. We got -3a e to the power of -3x. Okay, we need to differentiate yp twice. Okay, so after we find yp double prime, okay, we differentiate from yp prime here. We got 9a e to the power of -3x. Okay, after that, we substitute yp, yp prime, and yp double prime into the given question here. Okay, we replace yp double prime into y double prime. Okay, like this. We replace yp prime into y single prime, like this. And we replace yp into y here. Okay, so we got this. Okay, and right hand side now equals to negative 3e to the power of negative 3x, right? Our yp double prime equals to 9ae to the power of negative 3x. And then yp prime, we multiply by 2, so we got negative 6ae to the power of negative 3x. Yp, we multiply by negative 3, so we got negative 3a e to the power of negative 3x. Okay? And after we simplify left hand side, we got 9a minus 6a minus 3a, which is equals to 0 e to the power of negative 3x. And we equate to right hand side equals to negative 3 e to the power of negative 3x. Okay, now we have both sides has term containing e to the power of negative 3x. Means 0 equals to negative 3. What? 0 equals to negative 3? This is impossible. And this is not logic. Alright, since if we write yp equals to ae to the power of negative 3x, after we find yp prime, yp double prime, and then we substitute into the given equation, and we got 0 equals to negative 3, which is not logic, so we must do something. Okay, what should we do? We need to modify yp, right? Alright, now, how to modify yp? We recall back in the previous slide under step 1. After we find the general solution yg, we got yg equals to c1e to the power of x plus c2e to the power of negative 3x. Okay? And if any term in the guess for yp is a solution to the complementary equation, we need to modify yp by multiplying the yp by x. Okay. Now we look at this. Okay. We have term containing c2e to the power of negative 3x. Alright. One of the term in yg is similar to term in yp because this is constant a and c2 also constant. And then we have e to the power of negative 3x, right? Alright, yp equals to ae to the power of negative 3x is similar to the term in yg, which is c2e to the power of negative 3x, right? So, in this case, we need to modify yp, right? How to modify yp? We multiply ae to the power of negative 3x by x, right? After we multiply ae to the power of negative 3x by x, so we got this. Modify yp equals to ax e to the power of negative 3x. Okay, so up to this point, we will use this yp. Okay, we not use this yp anymore. Alright, so at this point, we need to find yp prime and yp double prime using this modify yp, right? Right. I repeat again. we not use this yp anymore, right? Now we use modify yp to find yp prime and yp double prime. So after we differentiate from modify yp, then we got yp prime equals to a e to the power of negative 3x minus 3ax e to the power of negative 3x. Okay, we differentiate using product rule, and after we simplify, we got this. Okay, and after that we need to find yp double prime, means we differentiate from yp single prime. So we got this negative 6a e to the power of negative 3x plus 9ax e to the power of negative 3x, right? Alright, how we got yp prime and yp double prime like this? Okay, from modify yp equals to ax e to the power of negative 3x, we have multiplication between variables, and the other one is the function containing variables. So we differentiate using product rule to find yp prime, right? I show you here. Okay, to find yp prime, we differentiate from modify yp. Okay, remember we not use this yp anymore, right? Okay, so our u, using product rule, our u equals to ax and v equals to e to the power of negative 3x. Then we find u prime equals to differentiate ax, we got a, and then from v, we find v prime, differentiate e to the power of negative 3x, we got negative 3 e to the power of negative 3x. Okay. After that, we substitute into product rule formula vu prime plus uv prime. Okay. We multiply v and u prime, so we got a e to the power of negative 3x, and then plus multiply u and v prime, so we got negative 3ax e to the power of negative 3x, right? That's why we got yp prime equals to a e to the power of negative 3x minus negative 3ax e to the power of negative 3x. Okay, we differentiate using product rule. Okay, because we have two multiplication of variables, right? Alright, and then from yp prime, we need to find yp double prime. Okay, so we differentiate from yp single prime. Okay, alright. To differentiate a e to the power of negative 3x, okay, this is multiplication by constant, so we just differentiate direct. Okay, we still have constant a, and then differentiate e to the power of negative 3x. We got negative 3a e to the power of negative 3x. But to differentiate this, since we have multiplication between variable and the other one is a function containing variable, so we need to differentiate using product rule. Okay, alright, from yp equals to a e to the power of negative 3x minus 3ax e to the power of negative 3x. After we differentiate this, we got this. Okay, from here, it is multiplication between constant. Okay, so no need to differentiate using product rule. Okay, we differentiate directly. So we got negative 3a e to the power of negative 3x. But to differentiate this function, we need to use product rule. Okay, we have constant negative 3 in front, and then to differentiate ae times e to the power of negative 3x, we use the same technique from here. Okay, our u equals to ax, v equals to negative 3, v equals to e to the power of negative 3x, then we find u prime and v prime, and then we substitute into product rule formula. So we got this, okay. After that, we expand, okay. And then from the first two terms here, okay, we can simplify. We got negative 6a e to the power of negative 3x, and then plus 9ax e to the power of negative 3x. Okay, we got this for yp double prime. Right? After that, we substitute, modify yp single prime and yp double prime into the given question here to find the value of a. Right? Okay. So after we substitute, we got this. Okay. We replace y double prime by yp double prime. Replace y single prime by yp single prime, and replace y by yp. Okay, and we still have the same right hand side, okay, which is negative 3 e to the power of negative 3x. Right? Alright, on the left hand side here, after we simplify, we got this. Okay, negative 4a e to the power of negative 3x equals to negative 3 e to the power of negative 3x. Right. How we got this? Okay, how we got negative 4a e to the power of negative 3x after we simplify left hand side here. Right. Look at this. Okay. The first row here means yp double prime. Okay, from here. Okay, yp double prime equals to negative 6a e to the power of negative 3x plus 9ax e to the power of negative 3x. Okay. The second row here means plus 2yp prime. Okay. We have yp prime here, and then we multiply by 2, so we got 2a e to the power of negative 3x, and then here we got negative 6a e, minus 6a x e to the power of negative 3x. Okay, this is plus 2 yp prime. Okay, yp prime we multiply by 2. Alright, and then the last row here is minus 3yp. Okay, from here, yp equals to ax e to the power of negative 3x. So minus 3 means times negative 3 means we have negative 3a x e to the power of negative 3x. Okay. To avoid error and easy to simplify, we arrange based on the same term. Okay. So we have same term here, term containing ax e to the power of negative 3x. So 9 minus 6 minus 3, okay, equals to 0. And then we have same term here containing ae to the power of negative 3x. So negative 6 plus 2 equals to negative 4. And then we have a e to the power of negative 3x. Alright? So after we simplify this, we got this. Okay? You can refer here. Okay? Alright. After that, by comparing the coefficient of, okay, now our goal is to find the value of a. Okay? Because after we find a means we done step 2, okay, which is to find the trial solution yp, right? Okay, so by comparing the coefficient of e to the power of negative 3x, okay, because both sides containing e to the power of negative 3x, okay, so we got negative for a equals to negative 3, okay, so a equals to negative 3 over negative 4, which is equals to positive 3 over 4. So this is the value of a, right? After find the value of a, so we substitute a equals to 3 over 4 into modify yp. Okay, so from modify yp equals to ax e to the power of negative 3x. Now we replace a equals to 3 over 4. So we got yp equals to 3 over 4x e to the power of negative 3x. Alright? After that, we continue with step 3. Find the solution y. Okay? Y equals to yg plus yp. Right? So, our y equals to yg from step 1 equals to c1e to the power of x plus c2e to the power of negative 3x. And then plus yp, okay, yp from step 2 equals to 3 over 4 x e to the power of negative 3x, okay. This is the general solution for the second order differential equation, non-homogeneous equation, okay. We modify yp, right? Since the question not given the initial condition, so we no need to find the value of C1 and C2. So this is the final answer for this question, right? This is the complete solution for this question, right? From step 1, find yg, step 2, find yp, and this is modify yp. We multiply the original yp by x, okay. And then step 3, we find y by y equals to yg plus yp, okay. We add yg here and yp here, so we got this, right? And this is the solution for yp prime, okay. How to differentiate, modify yp to find yp prime, and this is how we differentiate yp prime to find yp double prime, right? Thank you. You can subscribe, like, and share to support this channel. Bye. Assalamualaikum.